Mike's the global technical director for global technical director of utilities and mapping at the Bentley system. He specializes in the microstation and does a lot of geological mapping for different applications. Welcome him.
Because I'm taller than she is. Any sufficiently advanced technology is indistinguishable from magic. That's a quote from Arthur C. Clarke, and it sums up how we're moved by new technology. There's no better place to discuss technology or magic than here in Las Vegas. Technology continues to move and expand at an exponential pace. We're always amazed every day at innovations we see, and it can be very terrifying to the next generation. I mean, how many of us spend a lot of time with our parents or our grandparents trying to help them with the technology of how to use their TV, their phone, or even their car and everything. It's kind of amazing. But I am truly honored to have this opportunity to share technology and advancements making smart cities more interactive to make it easier for those people. I'm Mark Schneider with Bentley Systems, as she was mentioning. My job title just changed as we're rolling into next year. I was over utilities and mapping, and so I've done a lot of work with utilities. My new role is actually I'm still a global technical manager, but now I am over integrated lifecycle solutions. Yeah, that's what I said. It's better than it was longer. But what that means, Bentley's a technology company, and I get the fun job of making the 350 applications we work together for infrastructure, because Bentley's an infrastructure company. And I'm not here to do a Bentley ad, it's kind of amazing as I look at it. And as we look at our world today, it's more connected than ever. We have technology that brings us together to build a better place to live. I've had the opportunity to work with Mike Andrews, who many of you in here know. We have a foundation that is called the Smart Competition that works on teaching high school kids how to use energies and buildings to be smarter, better places, and we're working on that. I mention that because when I have an opportunity to go out and talk to high school kids, I like to mention how it gives us the ability to put our fingerprints on the world. So all of you guys, as we talk about technology, I'm hoping that I inspire you in what you see and looking at how you can change the world, not just America, not just the US, but the world. I've had the opportunity as a global director to travel around and to think, someday I'll be able to go to India or Africa and drink the water is a very exciting thing. But as we look at the world that we're sitting on right now, the population is now over almost 7.5 billion people right now. So that is just today alone, we've added 200,000 more people on the planet Earth. By the turn of the century, we're looking at having over 11 billion people. That's 3.5 billion people more than we have today. Sorry, wasn't quite done with that thought. And it's very important to realize that half the population live in cities. So we have to it's very important that we understand how we can build smarter, better buildings that you can maintain the infrastructure for this kind of growth coming forward. I've had the opportunity to talk about smart cities around the world too, which is always interesting. And so this description that I have up here came from when I was speaking in India, talking about smart cities and looking at it. And I realized when I was in India that one thing that this description, it talks about how, we're wanting to smarter cities, leveraging the technology and the data to enhance the performance of well-being of the citizens that we have. But as I looked at this definition, I realized it's missing sustainability is one of those topics and categories that we need that is so important. And it's important that we realize that we need sustainable infrastructure is required to sustain our society, the environment, and probably most important that we need to sustain and educate our youth the next generation of professionals. Because sustaining the professionals and fostering future generations of smart vision professionals is what this world needs to meet that goal. So a little history lesson, because I realize that a lot of you don't understand some of the terminologies and where technologies come, really in a fairly short amount of time. If we look at the evolution of technology, kind of in a mapping and city-centric world, over the past 20 or 30 years, we've actually seen a progression from going from 2D maps and GIS, and GIS is Geographical Information Systems. It's the stuff that they use so your phone will allow you to drive where you need to go. And then as it continued, we got into thematic mapping and doing a lot of looking at how we can track information, and using thematic maps and heat maps. And then we got into the BIM, and BIM is Building Information Modeling. I'll be talking a little bit about that. And that started playing a major role in the development of cities and the maintenance and the operation of those cities. And now, that last picture on the end, you're seeing, we're now learning, and it's kind of the focus of what I'm going to be talking about, I think it's exciting, is the potential of leveraging reality modeling for simulations, optioneering, the benefits of enhancing project delivery, construction, operations, maintenance of an entire city and world. So it's going through the society. So I think it'll be an interesting thing for you to look at. So how does this relate to smart cities? Many have looked at BIM, or Building Information Modeling, as just the structure, the building that we're in. But really it's not. It's all about all of the infrastructure that is built, that we know of for our civilization today. And buildings are just one small part of that. So as we look at, public infrastructure is managed by, managed and maintained by local and regional, national authorities who are tasked with delivering more for less. And historically, those have been in different silos, which is kind of what this is representing. You'll have your different agencies, they're all allowed, and they're all handing off data manually between each other. What we really are looking at doing is the smart city requires that we work together and leverage all of that data by federating it all together into a single source, and that's what we're going to be showing, including moving into the operations of new projects that automatically just become part of that living body. This connected environment that we're talking about that ties the city asset information data set, data management, into that smart infrastructure model. This is the living model that the data resides about, is combined by three major components, and they all rely around what you guys are about. The first one being IT, or the information technology. This provides that foundation for the connected environment with the servers, the services, the networks, the applications, the mobile apps that all put the information in the hands of the users, or in the hands of the citizens in many cases. Then we have nowadays cloud technology providing the flexibility for storage and mass processing of that data is now possible that we didn't have. Next is the engineering technology that's providing the building models, the documentation, the data, to construct and build and engineer these assets. Lastly, we have the operational technology that's becoming more important and more tied to the engineering, which is tied more to the IT. It's all merging together into one big operation. And this enables the living model of that BIM, if you will, the bigger BIM, operational for the maintenance, data, and efficiencies. So I work for Bentley, and at Bentley we celebrate our successes of our users and cities and governments and everyone that uses our technology. Here's 4 examples of cities that use our solutions to create intelligent 3D city models. We have City of Newcastle, which is in New South Wales in Australia, Helsinki, Finland, we have Montreal and Quebec in Canada, are just 4. We have books and books, and actually I'll talk at the end about these books down here. Those are 4 examples of cities that are old cities that are large and have lots of information that we needed, that the infrastructure had to be maintained while the services were improved and moved forward. And so that's part of what we want to talk about, is how we can move the cities forward in order to build better 3D cities and for a better experience. This is an example of one of the projects that was done, which is the London Crossrail project, or Crossrail in the UK. It's in London. And as you can see, this is an app that was put together that used our BIM model, and in this case it's on an iPad, so that you could navigate through it and tour the inside of what the terminal is. You could look at the maps, you could look at the station, you could look at the underground tunnels. It gave us the ability to have a single interface to actually experience where I need to go. And if you've ever traveled international and you knew you had to change trains inside of a building, you know that can be kind of hard. This also could be used in order to look at operational data, such as the mechanical or electrical information inside of the building. It is all inside that model as well, that app. On top of that big BIM project has to do with all the utilities that are underneath, the subsurface utilities. The model of the utilities provides the ability for clash detection, the ability to design around existing underground infrastructure. And all this modeling and technology has come a long way in the past 20 years. But this is where I think it gets kind of fun. We're now entering what I see is the advanced technology that is indistinguishable from magic part, the reality modeling. Reality modeling provides the ability to do detailed 3D mesh models from two-dimensional photographs. The images can be taken from aerial imagery, can be taken from drones, sensors mounted on automobiles or vehicles, cameras, cell phones, you name it. We can put that information together. That sound cool? You interested in that? So I'm going to give you a couple examples as we start to walk. This is a city. So in this case, we put a camera on a vehicle and ran down the street, kind of like Google does. And we made this mesh model. So I turned off the color so that you could experience what the mesh model looked like without the color. You can see the actual city. Now as I turn the color back on, you truly comes to life and see how much detail is inside that model. It is kind of amazing, isn't it? Can you imagine what street view would look like if you were doing this? I get excited. Okay, so that's a street. Now what if I needed to do inside of a building like this building? Actually, as we were talking, the maintenance guy was telling me that they came in and did the LiDAR scanning. Anybody familiar with LiDAR scanning here? So LiDAR scanning is really cool, and we do this, and this integrates with LiDAR scanning as well. But in this case, we have two-dimensional pictures. So imagine this. We have a cathedral with a little bit of detail inside of it. In this case, this was taken with a regular camera, and using the software automatically locates the picture. So as I identify each picture that I loaded into the software, it shows me what that picture was like. Then it builds a three-dimensional representation to map where each of those pictures actually belong, and this is what this map represents. So in the bottom, I can see each camera sensor location, and as I touch them, I get a little key map that shows me the image that's looking at that point. Mind-boggling, isn't it? So now we've just processed this data, and I did some time lapse here because it takes a little bit longer than that, but this is the actual mesh that comes out. So if I turn the color off, that's the mesh model, and as I zoom in, it's scalable so you get more triangles. I can now navigate through it, I can measure areas, I can measure radiuses, I can measure lengths of things, and the accuracy is plus or minus 2 pixels that you have on the camera, so that's pretty amazing. I can now navigate through this model any way that I want, totally free. And if I can turn the mesh on and you can see kind of how it's superimposed. Now I hope this is getting your mind going, is it? Hope so. And, you know, does it look like magic to you? It does to me. I mean, and as we look at the different opportunities that we have. Now, I gave you the idea of what it looked like with the street, and I gave you an idea of what it looked like with the building. The next little section I have is actually going to talk about a digital campus that we have. In this case, you can see that there's a little bit of detail here. This is Penn State, and this was done by, you know, just flying over it with an airplane. I'll talk about it a little bit, and then it created the 3D models. So key to the model is nice. I love to have this 3D model where I can go and navigate through it. But part of the rest of the story is the rest of that BIM story. How do I take that information, be it the design models that the architects and engineers designed, construction models that tell us how we need to build what we have, space management so that the facility people can manage the space, GIS where we want to take the information that the mapping information and utility information, facility or maintenance operations that come from SCADA data on equipment, project management data, financial data, and we want to be able to tie that into that mesh model. Would that be cool? I think so. On the far left side, there's actually a diagram that kind of shows some of the different phases that this comes into play of where this mesh model is fitting into this puzzle. The amazing thing is we can capture this data through multiple ways. We can use your cell phone, we can use cameras, we can use drones, we can use LiDAR data, any kind of a scanning device our software will take and hyper-red it into this 3D mesh model. So if you have LiDAR data, if you have cell phones, if you have an airplane or a drone, you can go get the data. So this is what the model looks like that we did for Penn State. So Penn State is 1,200 acres, that's about 2 square miles. This was flown in about 1 hour with a Cessna airplane at 1,000 feet. So what we did is we just basically flew around it and did some loops around it in an airplane, stuck our head out the window with the camera and took pictures and built this 3D mesh model of the entire campus. So, you know, when you look at it, that's just like amazing. Now, I don't normally talk about this in most audiences because it's kind of geekish, but I think we're in a room of geeks, so I'm going to. And in the back end, we have this really cool technology that is, it's called iModel Transformation Service. We start by creating what we call an iModel. An iModel is a format that is viewed on multiple platforms. So it doesn't matter if you're on a Windows, iOS, Android devices, whatever you are. It's based, an iModel is a SQL-lite container, if you will. In this container, you can connect to it with an ODBC source. If you want to connect to it with an Excel spreadsheet to gather data. But this transformer product lets me take databases that comes from multiple locations. So I take my asset operations, I take my project data, I take GIS data, I take building floor plans, and it automatically maps it to where it belongs and adds all that intelligence to it. Now, so this is the black magic that happens between, you know, behind on the server. So normal people wouldn't necessarily see that little thing going down, but as engineers, you're going to see a lot of things with numbers going down. So or maybe not. I've seen a lot of that. So now that we've ran it through that transformer, I can now select a building. And when I select a building, on the side, it actually shows me all of the data about that building. So this came from the GIS data. So it's telling me, and the GIS data then tied the data to work orders. So I can select any particular work order and identify what work needs to be done, all from this, using this 3-dimensional mesh model as the interface. Now when I select it, there was a link, and the link puts it into what ProjectWise is our engineering content management. It's a managed environment that automatically, by selecting it from what I picked, it's going into the system, finding the PDF of the document, telling what it is we need to do. So you can see how I have a building and I was able to go and get it, and I can select it, and view the information on the map very quickly, easily, and go query and locate that information. I can also not only look at, in this case, I want to go and query and look for a Maximo, a totally different system, a Maximo work order that has to do with preventative maintenance. So it doesn't matter what source it came from, it's mapping it and it's handing off that data. Now, if those people in the room that have worked with lots of systems and the complexity of making them all work together, this is kind of amazing. So the next thing that one might need to do is go in and actually do some more complex queries. So it's nice that I can go and pick the buildings, define the buildings, but in this case I want to build a query and I want to look for all projects that have buildings that are waiting for materials to be ordered or materials to arrive. So I simply build a save search. I can save that search so normal people don't have to actually do the query. Again, I'm in a room of quick geeks, so you're getting the opportunity to see some of the great geek work there. So by going out and looking at it, now when I touch my save search, I just touch it, all those purple buildings are showing me all of the buildings that are waiting for material. So if I'm a facility guy needing to maintain those buildings, I can do that. But I'm a maintenance guy that needs to know what's the priority. So I'm now going to take that same search, slight modification to say, show me the buildings that are a priority, and now I have fewer buildings that I can go and address what I need to go look at and get that information. So it's all taking that information, giving a different way and a different approach to go look at that information. I can also, in this case, I'm doing a query and saying, I want to find all the reports that were due or done after July 1st. So even though there's no spatial connection to it, it's able to go and locate data that has no spatial information. It's still tied to the building, so it knows where it belongs. All very interesting, I think, from looking at where we can go with that technology. And once we have the building, sometimes we maybe have a new building that needs to be put into the project. So we can take the mesh model and superimpose a new building into that existing mesh model. So I can go and do visualization analysis to say, what is this going to look like once I put that building into this, into the property. So that's kind of just a nice, we've been doing that for a long time, but we haven't had that nice mesh model. We go to a lot of effort to fake stuff in it, but we didn't quite have it that way. The other thing that is important is the ability to look at the underground utilities. The underground utilities in this case came from the GIS data. So even though those lines weren't on the photo, it's able to superimpose where those lines belong, and I can then identify what utilities they are by the color, and I can select the utilities and see, again, all of the attribute data that's on the data that was in the GIS. So you can see, you can select what type of material it is. You could have information on the installation date, if there's warranties or information, or if they have any maintenance requirements that need to be done. Likewise, we've got electrical conduit there for you, a 2-inch electrical conduit. So you can go and view it, see it, and put the information in. And some of our technology, all of this is available on iPads and phones, which you'll be seeing a little bit later. So facility data is also very important. So we have all these nice mesh models, but sometimes we need to look at the floor plans of the buildings. And again, not everyone knows how to find all the right data to put it in their hands. So in this case, we turn off the shell of that building, and then we turn on the building floor plans. In this case, you got the basement floor plan, and then we'll have the first floor, and then each floor actually has a floor plan so that you can see, identify the areas. Again, you could query, you could search, you can look at it. But for a little bit of a more graphical interface, we want to be able to select a room that's actually on here and then look at the information. So once I have those floor plans on my model, I simply touch it, and it automatically opens up the pane that tells me what the square footage of that building is, what's the use of that building. Any information that you have in your database could be inside that little model. And the amazing thing is all of this information can be contained in a single file that's mobile on your iPad or over the web. And to take it one more level, so in this case, maybe we want to look at what the heat maps look like. So I have the floor plan. I say, okay, now show me which rooms are hotter, which rooms are colder. And again, I can query, touch those rooms. I can graphically see through the thematic mapping what colors tell me which ones are hot or not. So I know which rooms I need to address and go look at. So as you can imagine, it's kind of fun to just see where the world maybe is coming. So as I showed earlier, where we had all those cameras came from different locations, right? All those pictures. The nice thing is, since those pictures were taken to build the model, I can backwards look at which pictures did it take to build what part of that model. So if I select a building on the screen, there'll be a bunch of red dots. So as I pan down, I can see those red dots. Each one of those represent one picture that was taken from the airplane that was flying around, so you can see what its flight path looked like. So the exciting part about that is maybe I want to go find which picture it is. By just hovering over those red dots, it's showing me a canopy of what area of the model is built from that photo, so I can go look and see what it is. Now by clicking on the document, it's going to go into ProjectWise again, and it's going to bring up the photo that was taken, so you can see the strut on the outside of the airplane is there, and the software automatically takes out things it doesn't need, like struts, moving cars, people. It automatically removes moving things. So as I go in and I look at each individual picture, you can go back. So again, if you're looking at building a bridge or anything else, it gives you that flexibility to go back and look at that data. Excited? Now, let's look at some new construction scenarios. So I have a building that I'm going to be building. So in this case, what we want to be able to do is look at what happened every week. So in this case, they programmed a drone. So once a week, the drone would automatically fly its set path around the building. It would get processed so that we can see exactly what happened in a particular week on this particular construction project. And guess what? If there's a problem or equipment that gets stolen or missing or something falls off, and we can also use it for flood rising. I didn't even add that to the thing, but it's kind of amazing. So the next thing that we need to deal with is the existing information, and I kind of wanted to pick something that was very electrical for you guys. So this example is kind of interesting. This shows where we flew around a substation, and we have some transformers. And since this software automatically will take any pictures we take and match the photos together, as I zoom in on the actual plate, I can see exactly what the plate says. In this case, I have a link on that plate. The software linked it to the live dashboard that's giving me all of the live data on how that transformer is performing. So Bentley offers operational software, and this is one of our softwares we all have, is dealing with that. So it's just tying that data together. I click on the link, and it brings up the dashboard, and I can see what's happening. I mean, again, that's pretty, that changes the game a little bit, you know? I thought it was pretty good just to be able to go look and read the plate on the side of it, but to be able to actually go look at the dashboard and see, you know, and it's, some of our utility companies using that technology, actually there was an issue where someone shot the oil pan on a transformer in a very, very, very remote location. And because of that, it lost its oil, and the intent was that it would catch on fire. But since they had dashboards like that, they were able to identify and found out that there was a problem with the transformer long before it became a problem. But if you can imagine having something that's remote, it takes 2 hours to drive to this silly thing, you know, you can fly something out there and go look and see what's going on and build a model and know before you can get there the other way. This is also used for underground things. This is a project that we did, I think it was about a year ago, but as an example of how they took the camera and went down inside of the sewer line and built a 3D line of the sewer. And that way they could look at what maintenance issues they have. And we've done that with cameras for a long time, but this allows us to actually look and get more into depth in some of the detail. what's happening. So if we can imagine what we're looking at right here, this is a combination of everything, all of the pieces mixed together. We have a reality model, in this case it was LiDAR data. We have ground penetrating radar mixed in with the GIS data showing where we think the utilities are. Mixed in, so you have the BIM, the radar, everything is put into, encapsulated into a single thing so that it gives you the ability to look at all of the information all at the same time. Conceptual design is another fast-moving and exciting thing in my life. And this gives us the ability to locate on a map exactly where a project is, in this case Philadelphia. The system goes out and finds the latest GIS and photo imagery, which it did. Now we can combine that with a mesh model of Philadelphia that we flew, which gets added to that mesh model. So in this case, we need to build a new bridge in a highway portion. So we're using a product we have called concept stations for conceptual design that lets us bring all this data together. And almost like SimCity, we can design a bridge where it's going to go. We can say, so you do select it, and it knows the rules. It says, okay, I have the out-ramp that has to go there. I rough it in, and then it makes it right. Now I just put a road in, now I'm turning it into a bridge. So I select a bridge type, and it automatically makes the bridge. Of course, we need to have street lights on this bridge, so I'm going to select it, and it's going to put the street lights according to my specs. Now, what's neat about this is it's not only building the bridge and the data, it did the cost estimate for our preliminary cost estimate. And also part of the product is our visualization, which is an RT, which is used by Hollywood too, but this is built in the product that lets you do the visualization, animation of all your cars. It ties into the traffic patterns and so light signaling, so it's all a nice, neat package for putting it together. And you start thinking and looking at where can we go with this technology. You know, I kind of made it a ramp as we're progressing along. And you look at this and think, you know, but there's, how do you take this, how do you figure out how to take the pictures? And part of what you need to do is understand part of the scalability of what this capability is. So to back up one step further, if you remember I was talking about how we flew with an airplane. And then sometimes you might need to go in and get more detail. So I have my cell phone and I go in and I take pictures. I'm going to take this off. So my problem is every time I turn my head, it went quiet. So I can take my cell phone and take some pictures. I can go through and fly another section with a drone. I can have the photos come from different sources. The software automatically meshes everything together, figures out what runs go to what, and puts it all together. So the reason why I mentioned that is the next thing I was going to show you is kind of scalability. You might get a little motion sickness here, so this is kind of a warning. So we got close to this one statue, and as we zoomed in, there was a lot of detail because we went into the detail. As we zoom out, a lot of the city, this one looks better because that one has a warp in it. But the city is, part of that's done from aerial photography, just top-down aerial where it did the map. The others came from photos that we added. And so here you have Paris, right? And so it's France, somewhere France. So this is one of Bentley's office is right there. But as you can see, as we navigated around, that is a lot of data. And the amazing thing is, like I said, with cloud computing and processing, and what we can actually do, it's turning into another interesting thing. Now what I want to do, there was the Pope came to Philadelphia. You may be aware of a papal visit, but what we did is they used this technology for all of the security, so they modeled all of Philadelphia, and they did this. So what I have is I have a video I'm going to run that kind of talks a little bit about what that project had.
Model of the city of Philadelphia, by the way, in a what we call a reality mesh format that can be used by every engineer of infrastructure in the city. never been accomplished at all, let alone to accomplish it from scratch in such a short time frame.
Software. For this particular project, we're capturing about a detailed square mile. Most of the photography we're capturing is going to be from the helicopter, but of course, there's only so close we can get to the objects, the buildings, the important structures. So we're also supplementing all this aerial photography with this going to be some ground-based photography. So that involves getting very close to the buildings and reconstructing 3D models of that from ground level imagery, which will add great fidelity and detail.
CAD drawings and do lots and lots of site surveys, but the ability to leverage this 3D reality modeling is absolutely a game changer for us.
A really important thing was it had to integrate seamlessly with MicroStation and all the associated modeling tools so that we could then begin to model all these temporary facilities directly in the model without having to go through a lot of translations and exports. We just want to work seamlessly with the reality model. And then also with the integration work that Ray Dunley and his team did, it did work seamlessly.
The amazing thing to me was when you capture these models, it captures the GPS coordinates, so we know exactly where on Earth the models are located. I can tell you 5 years ago, someone told me this was possible. To produce a model of this accuracy from pictures, I would not. I'm still having a hard time believing it works as well as it does. Prior to this technology, surveying was something done by specialists once. And now I think where we are, this convergence, if you like the Internet of Things, where things are connected together, they can be connected together now in the context of a 3D model captured with reality modeling as it evolves, is constructed and operated. And a special event was a chance to compress that timeline and experiment and learn together about this new potential.
The fact that we test drove it on a 60-acre site just gives us all the confidence in the world that the next arena, opera house, convention center, or 60-acre site that we choose to employ this tool will be successful again and again. And this will be a tool that we use many, many times into the future.
Congratulations to all who made the event so successful. We think we helped to a degree, and we learned to such a degree that we think we can help more in the future. Having done it for Philadelphia, let's go on from here to do it for the world.
So that sums it up pretty cool, doesn't it? So one thing I'd like to ask you guys is this something that you'd like to look at and be able to see on your phone and device? Maybe you might. So what I'd like you to do is if you have a smartphone or an iPad or something like that, I'm going to set up my little hotspot here, and what I'm going to do is direct you. So there's two URLs right there. The top one is Real World Capture. It's an organization that actually Bentley started. There's many companies that will actually do data. But the second one is one that there's a data model that you can actually go get, or there's several, I think. And I'm going to display them. And if you go to enter, I don't know why they put Realty model, that is where the URL is. I didn't create it. But so look at that URL that's on the second one. And if you want to go ahead and if you have, it works a little bit better in Chrome. So if you want to do that, I'm going to second one for what we're doing. And let me get my... I'll do it on my phone, so this takes me a second to bring my phone up here, and I may see more stuff than you're going to see, and I'd like to know when you tell me, because you see my screen, I get a whole bunch of models, and yours might jump right into a particular model. So if you type in that, and again, it's not reality modeling, it should be, and it will be in the future. Reality model, modeling-pw, which is project.bentley.com. Anybody have it? Did it display something? Did you get a list like I have, or did it not? Yes? Okay, so if you have that list like I have on there, scroll all the way down to where you see, you can either do Penn State, or is someone here, California folks? There's a, yeah, Berkeley's in there as well. So you can do Berkeley, or you can do Penn State if you wish. I'll go ahead and select the Penn State, the top Penn State one. What it's doing is it's dynamically loading up that image. So you think, well, that's a little bit slow, but if you consider how much data that is, that's pretty amazing. With the gestures, I was hoping to hold the mic, but I really need my fingers to gesture. I'm going to put both my fingers on the thing to actually kind of scroll up, and then spread my fingers around to move in, and then I can navigate, and it will recache as I'm going. So you can see how fast you can actually, thinking that this model is actually coming up, cache over the web, and you have basically a 2 square mile area. And if you're familiar with Berkeley and you go to the Berkeley site, you can look at buildings that you're familiar with. But this is an amazing way to look at how you can use that technology. So how many people were able to get it connected? Looks like all the young people. So does that look cool? I mean, that's pretty amazing, isn't it? And if you go to the first URL, there's a site where they actually have some videos, and they have some things that you can download. If you go to Bentley's website, www.bentley.com, and you look at context capture, they actually have models you can download and a free viewer you can go play with and do some pretty amazing, better watch out, bring that back to my holster while it's still on. So that's kind of interesting, but I thought it'd be good for you to be able to see and feel and see how much that changes the world as far as being able to get to the data. Now the model I have there doesn't have all that GIS data embedded in it yet, but I'm just kind of giving you an idea of kind of where that's going. If you can imagine having something on your phone, you call up the city, you go to the building you want, you click on it and be able to get to data. Now just like this data is protected in our ProjectWise secure place, so the data could only appear to people that have the rights to go get it. That's why it's having you go look at some particular buildings and not others, because you might get an error that says you don't have the rights to go look at it. But with that, let me go back. Any questions on that? Any thoughts? I'm not quite to the question thing yet. Wait a second. I'm trying to get. Oh, I know what you did. Yes. Of course. That's obvious. And actually, I'll talk a little bit about that. Let me turn off my. Let me turn this off so I can make it go away. It's really hard to drive without on the screen. Okay, that's what I want. Okay, so before we get into that, I did want to mention Bentley has an academic program, and I know we have a lot of people in here that are young and have either come from the academic world or in the academic world. And I have some academic brochures here. Bentley offers at an amazingly low rate the ability to have 50 different applications, and when a school is teaching it, every student gets the applications for free, including some of the visualization software we have, and including the context capture we were showing. So for the educators, we have that. For the students, they get the software. And then we also have the ability for users or engineering companies to adopt schools, and which is a good opportunity to make those connections you need. Up here also, I have some year in infrastructure books, and these are really good if you want to figure out what companies are doing some amazing things. Every year, Bentley has companies that are using our technology submit projects, and all of these projects are from companies that are using technology and innovation in amazing ways. And at the back are the names of the companies that are doing that. So if you're looking for work, I'm just saying. So I brought several of those books. There's not enough for everybody. But I did bring those, also the academic brochure and some calendars if anybody would like those. The cards that are by the academic is the guy that's over the West Coast area for academic. So the cards there, I have my cards, I'd be happy to share with anybody also. Yeah, so with that, so question, I wanted to leave some time for some questions. I thought there might be a couple. And one of them came up with the asking about the virtual reality. So Bentley's been doing a lot in the area of virtual reality and augmented reality. So virtual reality gives me the ability to take all of the stuff we're using, and most of what you've seen is used by the visualizations, also used in Hollywood. So sometimes you want to be able to walk inside, and if I'm doing augmented reality, it's actually taking my surroundings, mapping out the room. So when I look at the room, I see the room just as it is, but I would also see where the electrical lines are actually behind, superimposed behind where they're at. Or if I looked at the ground, I would see utility lines under the ground coming from GIS that's superimposed with reality. So that's augmented reality versus virtual reality. We also are doing a lot of work with holograms, meaning that I could be in a building and I can have my building plan sitting on the table, but it's not really there. Or I can, so we're doing engineering holograms, and that gives the ability to actually walk into a place where I'm going to be putting, equipment, and I can see the equipment where it's going to be later on down the road. So it's kind of exciting. Yeah.
For the lighting, you mentioned that the plane you put for the Penn State model was up there for a full hour. Imagine you had to normalize the lighting somehow. Yeah.
Well, so there's different things that it does, and there's some different tricks that are used. And even when you take the photos, if you look on our website, we have a document on what to do to take the best pictures to make it work. And we're actually working with drone companies to pre-program drones so that the people need to know less and it's going to do more. But yes, you're absolutely, so like as an example, people that do things wrong will be taking a picture, and usually you'll see it because of bright lights behind it and the camera thinks it's focusing over there, which makes the picture not as good as it could have been. And you want less shadows if you can have it, so the ideal thing to have would be some high clouds or something that does it, or high in mid-afternoon. But it's smart enough that it ties everything together to put it together. So if you have enough photos, like Philadelphia, trying to fly all of that Philadelphia, they did. They flew with helicopters, they flew with pictures, and the system automatically meshes them together and balances it out. I mean, it's quite amazing when you mind-boggling when you think. And also something I didn't mention, this is very, very important. So a lot of what we're doing has to do with, similar to the face recognition software that they have, but it's stuff recognition. So automatically what we're working on is the ability, so it will know, if it sees a street sign, it knows that it's a street sign, it's tagged as an asset that's a stop sign. If it's a street sign, it knows it's a street sign, and for that matter, it can read the street name on the street sign. So, I mean, we're working on a lot of intelligence, and we've actually done it so that if it sees a window or a door, it knows it's a solid door, it knows, there's things that we're trying to teach it to become smarter and smarter, and then mapping it with the assets is just pretty amazing. I think there's another, yeah.
So as far as the scalability goes, I noticed in the software it shows you kind of the envelope of what the image covers. But is there any way to take that backwards? So let's say if you've flown a plane around and took some pictures, and didn't happen to capture a certain angle of the building, could it tell you that you need to go and get this particular profile?
So what it does, and this is really kind of amazing, so it will take photos and figure out what it needs or not. And we now give you the ability to do video, and it will automatically take out many of the videos. It doesn't try to process them all because it would just take too long. But it automatically looks at it, analyzes, and says, okay, these are the frames that I need to build my model. So I think in the future you'll see more of that because it just makes it safer. And it does, and what it does do is it gives you the ability to go back and take pictures later and just add them. So when I built a model and I see that the back of a structure isn't there, then I just go take those other pictures and come and add and put them back in, reprocess it, and it puts them in. So it ties it together. It's magic. Yes?
So I'm just trying to think from more humanitarian benefit of this tool. For example, whatever models you are creating, they are based on the mesh of a structure, right? So if an earthquake happens in some area or in some region, and that building gets destroyed, so is there any backup for that? Because the mesh for that structure will be different now.
That's a very interesting point. It has to really. I'm going to expand what you said. And then he's asking about if there's differences that happen between dates on structures in this case. And actually one of the first uses that we started using the software for as we were developing it had to do with mining, it had to do with earthwork, and it had to do with looking at the differences between things. But we weren't looking at it from the perspective of, oh, we need to fix the model. We used it so we knew that this much earth was moved. We could do the volume calculation based on the two meshes, or we could go out and inspect a bridge and we are doing that right now, a bridge inspection, and we actually are doing technology that's using it where you can actually see the vibration of the bridge and we can slow it down, and so there's some deflection and some things that it's where you're actually using it on top of what it is, but it's so you're not if something moved, you'd have to go out and reshoot it. It's not changing. I mean, you could actually do modification to it, but it'd take you longer to survey it. Yeah.
Another thing which comes to my mind when you were showing the numbers, like how much expenditure you have to incur on a bridge, then what if happens, like if you want to estimate that how much is the loss happened after some kind of a disaster. So like for example, now you have the reference image and you have the structures after any kind of natural calamity. By calculating the error, you can estimate that how much loss happened to the entire community or an entire area. Just on top of it.
Well, again, one of those things we've actually done for flood. They've used actually this software where they've actually mapped a pre-flood, post-flood, more from a flood than other disasters or mudslides. So I've seen that it wasn't tied to the cost. The cost that I was showing you was in the conceptual design, and those costs, just to be clear, are not the real costs. So optioneering, we have it for site, we have it for rail, we have it for road. Those site optioneering are designed to figure out, I need to design a highway between here, and it needs to go through mountains with some tunnels. About which is the least expensive place to put it, and then once I've done my preliminary design and found the best option, we export that into our road design, our rail design, or our site design software that does the real design. Yeah?
You listed the different customers that you guys already have, and most of them are cities. Are they higher level?
We have more than I can mention.
Okay.
Yeah, I mean, I just, those are places I've been, right? So yeah, I mean, yeah, so I mean, even if you look at these books, just from last year, you'll see tons of cities around here. And government, Army Corps of Engineers, if any of you guys have heard of them before, they